Kia ora guys, welcome back to the Physical World video series. In this video, you're going to be learning about balanced and unbalanced forces. The first question I'd like to ask you is, why do you think you have to wear seatbelts inside cars? Keep that question in mind as you learn about balanced forces, the Newton's first law of motion, and unbalanced forces, Newton's second law of motion. And by the end of this lesson, you should be able to describe and give examples of Newton's first law of motion, and describe and give examples of Newton's second law of motion. So, Newton's first law of motion, which is also called the law of inertia, states that if forces acting on an object are balanced, then the object will either stay stationary, so at rest, not moving, or carry on at a constant speed, at the same direction and the same shape. So that means that when two forces acting on an object are equal in size but act in opposite directions, we say that the forces are balanced. So examples of that are this box here, which is held by a rope, and there's tension force acting upwards on the box at 5,000 newtons. There's also weight force acting downwards on the box at 5,000 newtons too. Because the tension force and the weight force are equal in size, 5,000 newtons, and they're acting in opposite directions, they're pulling against each other, we say that these forces are balanced. So what's going to happen to this crate, this box? Well, it's going to stay stationary. It's not going to go anywhere. Now, it could be going at a constant speed and at the same direction, but for now, I'm just telling you guys that this box, the context of this box, is that it is dangling in the air. Let's look at this book here. The forces acting on it are support force coming from the table, and the size of that support force is 5 newtons. But there's also weight force acting downwards on this book, and it's at 5 newtons. So, forces acting on this book are equal in size, 5 newtons upwards and 5 newtons downwards. And as I said, they're going in opposite directions. So we say they're balanced forces. And this object, this book, will remain stationary on the table and it won't change shape. It's not going anywhere either. Now I said that this first law of motion is also called the law of inertia. Now inertia is the tendency for an object to resist any change in its state of motion. Objects don't really want to change shape. They don't really want to change direction or change speed. And this concept of inertia is shown really well by this video. So as you saw in that video, objects like all of the plates and the forks and the candles and the flowers on that table resisted any change in its state of motion. They were stationary and they resisted any change to that. So they remained stationary and did not move even when the tablecloth was pulled from underneath it. This video also shows inertia in raw and hard-boiled eggs. I'm not going to play this video, you can watch it in your own time. And I asked in the beginning of this tutorial, seat belts are needed to be worn whenever you're in a car. And that's because seat belts and other safety measures like headrests that are placed in cars protect you from the effects of inertia. So when you're driving in a car, your body is moving in a constant motion forward, right? But as you stop abruptly in a car crash, your body still want to keep going forward. It's going to want to resist a change in motion. It's going to want to resist being stationary. And so it's going to keep going forward, and a seatbelt is there to stop your body from getting flung right through the windshield. Newton's second law of motion states that if forces acting on an object are unbalanced, then the object will either change shape, accelerate or decelerate, or move in a different direction. So this means that when there is a change in the shape or the movement or the direction of something, we know that the forces acting on it are unbalanced, or they're unequal forces. So for example, there are unbalanced forces acting on this truck because there's a bigger force of thrust going at 100 newtons going forward, whereas there's a smaller force of friction or air resistance going at 60 newtons backwards. Because the force is larger going forward than it is going backwards, the truck is going to speed up. It's going to accelerate forward. So Newton's first law of motion is all about balanced forces, whereas Newton's second law of motion is all about unbalanced forces. Here is a really good video that I recommend you guys watch after this video. It explains balanced and unbalanced forces really well. So by now you should be able to describe and give examples of Newton's first law of motion and describe and give examples of Newton's second law of motion. Thanks for watching, and I'll see you in the next video.